Alrighty, so the last concept that I want to cover regarding these ideas are tides. So tides have a really long period. And what's interesting with tides is, especially in comparison to the other other waves and how they're generated, tides are disturbed by gravity and also restored by gravity. So they are formed and, restored by gravity. And it's the gravitational pull of, let's think about it for a second, let's predict what would have such a gravitational force on our planet's oceans that it would move them. Turns out that it's the sun and the moon. So the gravitational pull from both the sun and the moon pulls the waters on our planet. So maybe you've seen tide variations before. Maybe you've gone to a beach during high tide or low tide and noticed that, wow, the beach seems to be either like kind of larger or smaller. And that's because during high tide, there's more water coming in. During low tide, it's a bit receded. Different locations will experience different variations in tide. Some places like this, oh, maybe it's only a couple of feet difference, whereas other locations can be a very massive difference. We'll talk about one location in particular called the Bay of Fundy that has a really intense change in tide. So if we were to imagine ourselves on the planet, so in this schematic, we're looking straight down onto the North Pole. And so when we're going through one solar day, we're rotating around the Earth, right? So, and then say the moon is right yonder, and this person looks like they're in the Men in Black, cracks me up. But when we're in line with the moon, essentially we have this sort of bulge of water outwards. So that's when we would be in high tide, and as the Earth rotates, about 8 hours later, then we'd be in a low tide, and 8 hours later we would once again be in low tide, but maybe have gone through a high tide, and then returning back to our starting place, being back in that high tide. But notice that the moon also moves just a scoochy bit as well. So kind of an interesting thing. So we have to add in that rotation of the Earth, that eastward rotation beneath these tidal bulges, and in one day the water levels can change at one stationary point. So as I said before, it's because of the sun and the moon, but maybe you've also noticed that some of these high tides are much higher than normal and some of the low tides are lower than normal. That's because we can either have the sun and the moon working together in terms of their gravitational pull, or away from each other, essentially. So for that, here's kind of just a little representation of that. So our monthly tidal cycles are about 29.5-ish days. So during our full moon and our new moon, the gravitational pull of the sun and the moon are working together, and so that those two gravitational forces allow for higher than normal high tides and lower than normal low tides. There's that largest sort of tidal range there, and then when our moon is in the quarter, then that is when the gravitational pulls are working against each other, essentially, and that's when we would have the lowest of high tides and the highest of low tides. And there's actually names for these, and those names are spring tide and neap tide. And you may have also heard the term king tide, and I believe that is when we are in our northern hemisphere winter, and that's when the Earth is a little bit closer to the sun than in our summertime. So the pull of the sun is even a little bit more, and so the tides then, or the high tides then, are even higher than normal, and the low tides are lower than normal. And here's just another visual representation of that. I like this visual representation a lot because it shows the solar tide and the lunar tide. So you can also see in this that the lunar tide is much more impactful than the solar tide because the moon is much closer to us than the sun, which is a good thing. I don't really want to be fried by the sun. I'm good. Also, please note that this is not an accurate representation of size in terms of the sun is not that big compared to the Earth, I promise. So here is that same representation, but here's kind of the spring and tide compared to regular tides. So this was from early November. This is the tide schedule for Half Moon Bay, I believe, right? So you can see that when we're in our new moon cycle, that's when our highest of high tides and then our lowest of low tides. Oh shoot, no, sorry. This is for that location in Australia. From the picture of the day a couple of days ago. So that location, as we can see on our kind of y-axis here, has a massive change in tide in one day. We also have the Bay of Fundy, which has a very similar sort of really intense change of tides. So it can be anywhere up to 50 feet, essentially, in one day. Let's see if this animation works. There it goes. So this is looking at the Bay of Fundy. So you can imagine that this would be really, really impactful for places that are, where you're a fisherman or something, right? You don't want to get stranded and then not be able to bring your boat in, or be like planning on going out, but then your boat's stranded, right? So then there's 3 main types of tidal patterns. And so, of course, the tides move the sea level up and down in all coastal regions, but there's some variations within that. So there's 3 main types of patterns. One is diurnal, the next is semi-diurnal, and then the third is mixed semi-diurnal. So diurnal, semi-diurnal, and mixed semi-diurnal. And this is generally what we would see around the world, kind of the various patterns. And you can see with the Americas, we experience all 3 tides, just depends on your location. But the West Coast in particular is a mixed semi-diurnal tide. So these types of tide patterns, the diurnal, that means that there's 1 high and 1 low in 1 lunar day, or excuse me, 1 solar day. So it may often look like there's 1 high tide and 1 low tide in 1 lunar day. This occurs in Alaska and the Gulf of Mexico. So you can see here there's 1 wavelength in this 24-hour period. Then semi-diurnal is 2 wavelengths. So 2 highs and 2 lows. This is generally seen on the east coast of the US and Africa. And then lastly, we have our mixed semi-diurnal. So there's still 2 highs and still 2 lows, but the 2 high tides are different from our 2 low tides. So there's 2 heights, really, in terms of that. So this is what we experience here on our US West Coast and also in Japan. Just because there's a difference in the high of the highs and low of the lows does not necessarily, that difference doesn't have to be massive. So if we look at, this is the tide table for Half Moon Bay, and if we were to compare the heights, right, if we're kind of zooming in here, the 2 highs, the only difference is 0.3 feet, right, on Thursday, and then on that Friday, only 0.1 foot, right? So the difference doesn't have to be huge, but we can definitely see that there's 2 highs and 2 lows in one day. So kind of a cool thing. Tides, of course, have various impacts of different regions. And again, with the impact either being 4 feet or 36 feet, can still be pretty intense for various regions. And that is tides. Thank you so much for listening.